to start the recording of. Okay, so yeah, so in an Angular project, you all see my screen, right? The VS Code.
Yeah.
Okay, so as you can see in the environment folder, you have two files, environment TS and environment prod TS. They are exactly the same at the beginning, except that the .prod has the production attribute set to true and the other one set to false. Okay, so I will explain how that works. But basically, it's just a file that exports one constant called environment, where you can store all the data your application need for configuration. Okay, it's a convention. You could put it in a database or whatever, but everything that you need to access quickly on the code and has to be centralized for ease of use should be there. And what Angular does is when you build your project, when you generate your distribution files, you can specify if you want to build a development version or a production version. So those files, environment prod, are the different configuration for each of those environments. So when you build a project as a development project, it will use this file, the environment file. But if you specify you want to build for distribution, it will use the other file. So it's quite easy. You can also configure more configurations and more files, whatever, and it's all automated. It's quite easy. But for the time being, with those two, we have more than enough. So here, I think the initial code is just this. So we have to add the configuration from Firebase, and I usually also create another variable called collections with the names of the collections that I will use in Firestore. Okay, to have them centralized and not to have to type the path everywhere on the code and just to centralize them. It's easier if you want to change the name of one collection, you just change it here, and then it will be impacted everywhere else on the code. Okay, so that was it for the configuration of the platform. So what we can do is let's talk about the next point, because this is probably more interesting. So before we start entering into the details of each code, each part or each file, let me explain what is a module in Angular. Module, it's quite easy to understand. Angular, like most of the frameworks, is a component-based framework. So it means that it tries to mimic the web component philosophy. So it tries to encapsulate everything into components to make things more independent from one to the other. But because of the new mobile era, we have to face something called lazy loading, or we need something called lazy loading. Lazy loading, as explained the first test session, is the possibility for your app not to load all your code on the first shot, but to wait for the code to be requested on a later time when it's needed. So it's obviously it gives greater performance to your mobile application when you're running on a low connection because of low bandwidth, or simply because you want to save some money. You don't want to download a lot of megabytes if you don't need them. So that's why you use in Angular. That's why you use modules. Modules are just, think about modules as a directory where you're going to reference everything you're going to need inside that part of the application. So the module is like the entry point of a new part of the application, and there you have to register everything you want to use for that module. Okay, so explain it in another way. When you first land on an app, probably the app will load a landing page with the name of the app and some logo, whatever, and very, very basic stuff, nothing else. If you click on login, for example, probably the app at this time will dynamically load all the code requested to provide the logging features. So behind the scene, what the app has is a module called probably login, or whatever you want to call it, that will encapsulate everything related to the login part. Okay, so that's why when you start an Angular application, you have the first module that is already inside the app is the app module, because the app component is the root component, and it's already there. And as you can see, you have only very, very, very few dependencies. You have the app component, which is the only component that the app will load at the beginning, and a browser module and the app routine module, which are both a Angular module that are required for the smallest thing possible. That's it, nothing else. So what we want to do usually in an app is, that's why I separated in different folders, is to create a core module to reference there everything we're going to need across the whole application, so that we're going to need from the start. And then in the shared module, we will reference everything that is needed in many other modules, but are probably not needed from the start. So we will probably load the shared module on the later stage, on the later time. And then inside the sections, well, each section should be, or should have, its own module, because probably you won't need to load all the section at the same time. You just need to load the section when you need them, or want to see them, or when the user requests to see them. So in the core module, this is how it looks like. It should look like. Okay. So we have several things. We have common module and ng module. Well, ng module is there. Common module, which is the definition of the module, so it's necessary for the module to work. And then we have other stuff that we've put ourselves. Okay. So what I usually, it's because it's easier to read, what I usually do is I create a constant called module, where I put all the module that I need, and then inside this is called a decorator. Inside the decorator, because this module is going to be used in other modules also, I will explain that later, you have to import those modules, but also export them. So instead of repeating what I'm writing here inside the import export, so I just create a constant and then I use it over there, okay, with the spread operator. Everybody is okay with the spread operator? Is it something that you need to explain, or is it okay? Michael, is it okay? You still have your hand raised.
Do I? Oh, yeah. Yeah, it's you usually use it to kind of access everything within an array or something like an array, right?
It's called destructuring. In case of an array, if I don't put the 3 dots, the spread operator before the modules, what we will have at the end is an array containing this, and then another array which is module. And I don't want that. What I want is the elements inside the array, the module array. So I use the spread operator, and it will just pour inside this array the content of module. Okay, that's the goal of the spread operator. Yeah, Harry?
Does the app module get loaded every time, no matter what, when you open the app?
Yeah, it's the entry point of Angular.
Okay, thanks.
So if you want to do a very, very, very basic Angular application. You don't do anything. You just use the app component, the app modules, and you do all your code over there. I mean, for example, if you're building an app that you're sure is going to be used only on desktop, you don't care about lazy loading, because probably they will be connected with very, very fast Wi-Fi or even Ethernet cable. So you don't care about latency, about data consuming, etc. So you don't need module, you don't need lazy loading. It's usually a best practice to do this like that, because you can then because you encapsulate everything around the module. So you could probably also just copy paste this module into another app if you need it, instead of having everything on a flat organization. But you could do that.
Got it.
Okay, so in our core module, I think we had this core module, I forgot something. I forgot to tell you. Since the app module is the entry point of the application, and as we said, we will need the core module everywhere in the app, we should import the core module here. So the app module will be the first module that Angular will call, and that's it. So at some point we have to tell Angular, okay, wait, just not only the app module, but you also have to load the core module, because I need it everywhere. So this is the place you have to input it. Okay, so you just put it there, and that's it. So the app module references the core module, and the core module references other stuff. I think it's safe to put the database access inside the core module, because we need it. Well, it's debatable, but I think we need it anyway. So it's the first thing you need to access some data. So inside these modules, you also have components and services, etc., etc. That will explain a little bit later. So once you have imported the module, these two modules, AngularFire Auth, the AngularFire module, you need to initialize your the library, the Firebase library that we've imported. So this is what is this line is doing. Is checking, is using the variable we created, the constant that we've created, the environment constant. Remember that in the environment constant here, we set the Firebase config, which is information we grab from the Firebase console, and we pass that as an argument to the initialize app. And from that point on, every time you want to use this library in your project to access Firestore services, it will work, because the configuration is loaded. So it's a good place to do that is inside the core module, or at the beginning of you just have to do it once. Yeah, Neville.
So on my core module, I seem to have an issue on the line 14. It's not recognizing environment. It's coming up with like an error underneath it, and also auth service on line 16. Okay,
so if you or could you share your screen, or do you have it?
Yeah. Sorry, it's not liking it for a reason.
Okay. Okay, so you you haven't imported the environment constant. So everything, I mean, I explained that. In your code, the code that start with ng module, etc.,
Mhm.
you're configuring stuff, and you're using variable constants and libraries, etc., that are written or based in other files. So this file doesn't know about any environment variable. It's not defined in your file.
Mhm.
So you have to import it from the file where it is.
Okay.
So what is cool about VS Code is that it can do that automatically. So if you put your cursor just after the T, okay, click there and just hit Control Space, and then see auto import. You just that's it. You just click enter, and then there you have it. It's the last line of your import statement. It looks like you haven't set the Firebase config in your environment variable. Just go down. It's the last file that you can see on your screen at the bottom of this tree. Yeah, you miss the. You have defined all the properties directly under environment. You should. What you can do is go back to your core module file. Okay, just copy Firebase config, the Firebase config word. Okay, go back to, once you copied it, you go back to your environment file. And then you go just after the false comma, after production false comma, you just hit enter after that to go to a new line. You paste the exactly, then colon, open the curly braces, delete the close one, and yeah, and then you go after measurement IDs after the comma,
Okay.
and then you can close it there, and then you have to put a comma because you need exactly. Then
Sure.
you can, if
Thank
you
you.
hit, okay, that's it. Now it knows it.
Thank you.
Okay. So same thing for, I think there's the service, the alt service. Just auto import it. Just click on after the word. Control space. Probably you haven't generated it. I don't know if you have generated the alt service.
At what point was I supposed to do that? Sorry, I obviously missed it.
No suggestion. It doesn't know where it is. Can you open the service folder in your directory tree? Yeah, just above where you are actually currently. Yeah, you haven't done it. You haven't generated the service, so obviously it doesn't know where it is.
At what point was that supposed to happen? Sorry, I obviously missed it.
Sorry?
At what point was I supposed to do that? I've obviously missed it.
Let me see. It's starting the code, core module, and then user service and alt service. It's the last point.
Okay.
Okay. So I try to go on. Oh, sorry, like this. Okay. So now what we've done is we've created a core module. We've imported common module, which is always there. We've also imported the Angular Fire Auth module and the Angular Firestar module, and we've initialized the Firestar library. Okay. That means that from now on, if we want to use any service component or whatever feature that requires authentication from the Firebase environment or the Firestore database, we can do it because we have loaded all the necessary code in our app to use them. Okay, that's why here, as a provider, the providers are all the services. Okay, so if you watch the course that I recommended you, you should know the difference between component and services. Services basically are the controllers, that they are the piece of code that manage all the relationship between the view and the data. So here we have a service, and Angular Firestore is also a service which is embedded in the Angular Firestore module. Okay. So next step. Any more question? Okay. So, yeah, never.
Sorry, so that line 6, when it's saying adding the constructor of the module, where's that going in?
Oh, sure. I forgot about that. Okay. So I forgot to explain something because it's so normal.
Sorry.
No, don't worry. It's so obvious when you use Angular that I forgot that probably you don't know what decorators are. So if you see this module, okay, this
Yep.
this is probably almost JavaScript, but this is not JavaScript. Okay, you cannot do that in JavaScript. This is called a decorator, which usually start with the @ symbol and then some function, blah, blah, whatever. This is like a helper for the class that you are defining afterward. Actually, if you see this, the export class core module, or using the service here, export class user service, it's just a class. It's not something particular. But using the decorator here, you can pass some parameters to tell Angular what this class will do inside the app. So here we say, this is going to be a module. So behind the scene, Angular knows what modules do, and how it should treat them. And same for services. When you define a services, you use the injectable. So usually, you don't have to write this because you use the CLI, and it will be created already with everything. So it's okay. So this is not actual code. It's just parameters. Let's say that. If you want to write code, you have to write code as in JavaScript inside the class. So in our case, if we want to use the Firebase, okay, it's set log level. Okay, you have to do it. Oh, sorry, I'm dumb. So it's a class. So a class, as I explained last time, can have a constructor, which is the function that is primarily called when the class is created. Okay. So until now, so we have this constructor. So when Angular will create this module, it will execute the constructor function, and this will execute this code. At the time being, this is all red because in this file, the compiler doesn't know what Firebase is. It's not defined. So you have to import it again. So you have to import it, I think like this. It's firebase.app. Okay. So it will be always the same. You will, in all components, services, modules, etc., you will always have a class with a decorator on top of it to explain and to tell Angular what kind of class or how to treat this class. And then inside the class, you will have a constructor if you need it, and as many functions as you want to define, them parameters or whatever, your code. So your code we all usually go there. Okay. This is not necessary. I usually do it at the beginning because it's quite helpful to make sure that you're not doing anything wrong with Firestore and not recurrently reading and writing data when you don't want to. If you set the log level to info or to debug, I think debug is also a valid value. It will verbose absolutely everything the library does with Firestore. It will spam your console, but at least you have a good feeling about what you're doing with the database. And since the database is charging you according to what the times or the documents, number of documents you read and write, it's a good thing at the beginning to start having this set to info or debug to make sure that you don't have like an infinite loop or something like that. Okay. So after that, we had to create the user service. I think I made a mistake here. It's not a big mistake. Usually, it's a convention. When you define a service that is going to be your interface between your application and the database, you usually use plural. Okay, but as you wish. It should be users service. That doesn't change anything. It's just a convention that you want to respect or not. So when you use the command, the ng generates service, it will generate a file like this without anything inside it, and from that, then you can start building it. So again, you set a constructor, and then inside this constructor, we're going to use what Angular called dependency injection. Well, it's a coding practice that is very common to many languages, and Angular also has it. So dependency injection means that you have some piece of code that need initialization, need to do some stuff before being ready to be used. And what is cool with dependency injection is that you don't have to worry about that. You just declare this service inside your constructor as an argument of your constructor, as a parameter, and Angular will take care of the rest. It will check the Angular Firestore service, check what it has to do with it to initialize it, and let you work with it correctly. So if I do that inside the constructor function, then on the body of the function, I can use the AFS variable and use Firestore directly. Make some queries to Firestore over there. It will be initialized already from the start, from the moment the component is created. So it's pretty easy to use. So this was the user service. That's the only thing we had to do at the beginning. And the auth service, exactly the same thing, but instead of using the Angular Firestore, we want to use the Angular Fire Auth, which is the service provided by the library for authentication. As the name is quite explicit. So, okay, so now that we have all this, okay, everything is saved. What is a good idea is to, in your terminal, run npm start, sorry, which will compile your code in memory, not in any file, and watch for the changes. So we're not at this point, the app does not do anything, but what I'm interested in is to see if it's compiling successfully, if I have any error in my code. For the time being, I don't have any error, which is normal because I haven't coded anything, so it's logical, no? So let's do something very easy. So not in the auth service, in the user service. So the user service will provide us with the tools to get some user from the database and to save some data on the database. So usually on your services, what you do is let's go step by step. Okay. First, let me think. I forgot. I think it's a good moment to explain the difference between public, private, and protected. The keywords, for example, here we have protected. Okay, so it's very easy. Let's say I'm inside my user service class. Okay, so if I define a variable as public, okay, I call it public variable equal whatever. I then can define also a private variable. Oops. Okay, I just have defined two variables inside my class, a private and a public one. So after that, if I use, for example, I say new user service, okay, it's not going to work. Okay, it's just to illustrate what is public and private. So if I do that, what I'm doing is I'm creating an instance of the user service, and I store this instance in the variable called u. If I check u and I check IntelliSense on VS Code, the only variable I can see here is the public variable. Okay, that means that the private variable only exists inside the class. So I can use it inside the class, but once I have instantiated the class and created an object with it, I don't have access to it. Okay, it's hidden for me. I just have the public one. Okay, is that clear? So it's a way. For example, imagine you have a service as we have here with no libraries. So we have to make an HTTP request to some website to parse the data, transform the data, and do a lot of stuff, and then return a variable with some information. So as you can imagine, inside our class, we're going to have a lot of code, and this code, actually, the other piece of the code that will use this service doesn't care about the implementation. It just cares about getting the results. Like here I'm using the service, so I'm just interested in getting the public variable. The private stuff, it's interesting inside the class, but not outside. It's just for you to hide your implementation for the user of your code. Okay, the protected one. Okay, protected variable. I will have the same issue here. I'm still only have the public variable. Okay, so what is the difference between protected and private? Well, it's a little bit complex. If I define another class called a user service child that extends user service, okay, so it's a child of user service, meaning that it will have everything that user service have, but I can put some more stuff on it. Here, I can use, I have to do a constructor, and then you have to use super null. And as you can see, if I use the keyword super, is a reference to the user service class. And if I look at what variable I have in super, I have the public and the protected one. I still don't have the private. The private is only available in the user service, but the protected variables are available in the user service and all the descendant, all the childs of this class. So that's why it's a little bit maybe complex, and we don't need that at the moment. Just remember that if you want to declare some code that is not interesting for the user of your service to use, declare it as protected. And if you want to declare some code that is going to be used outside of implementation, define it as public. That's it. So end of the story of the public, private, and protected. It is basic object-oriented programming. So back to our app. So in the user service, we would need a method or a function to retrieve a user and another function to save a user into Firestore. Okay. So both of those functions have to be public function because we're going to use them outside of the service. It's the goal of it. So we define the function like this: get user by email, for example. And I get email here. It's a string. Okay. So here I'm just defining a function inside the user service class called get user by email. Okay, and that's it. And how can I retrieve the data from Firestore? You use this variable, the Angular Firestore library that we've loaded here, so the AFS, and then you have, thanks to IntelliSense, you have all the potential functions and method that you can use. So here, what we want is a specific document. So we can use a document, or we can, let's say, the long way. We know that the users will be stored in the user collection. Okay. So what I usually do for that is first I define a constant called user collection. And remember that we had specified it in our environment. In the environment file, we had defined a variable called collection. Inside collection, we have all the names of the collections. Okay. So that's what I use. User call here is going to be set to the variable that we have specified here. So it will be this text. Okay. So back to our function. So I'm requesting inside the user collection a specific document. Okay. And here there's a decision we have to make. So as you know, in Firestore, you save JavaScript objects, and those objects have to have an ID, unique ID. Okay. Like any other database, if you want to identify a record or a document in a database, you have to find a way to uniquely identify it. So usually you use an ID. By default, if you don't specify an ID when you save a document, Firestore will generate a random, I don't remember if it's 17 or 20 digits or alphanumeric digits to create a unique ID. But it's not necessary. You can use whatever you wish as an ID. Okay. So here we have a choice. In our user collection, we are gonna store all the people, all the users that register in the app. And since we've said that the easiest way to help people to register is to use their email account, like from social network, for example, which is the easiest part. It's probably a good idea to use the email as the ID of a user because it's uniquely identified one person. Doesn't mean that one person only have one email, but at least one email is just one person. Okay, so that's usually this have one inconvenience, which is if this person changes his email, then he will have to log in again or to sign up again. Okay, but yeah, let's not complicate too much things. I think that using the email as an ID is a good idea here for application because it's simple, and the probability that people will not or will change their email is very low. So since the email will be the ID of our documents, of the user document, we can directly target the document giving the email. So document here, as you see in the documentation, here you have a path, which is basically the ID that you need. And then comes probably the most difficult part for Firestore. Here you have different possibilities. You have get, or snapshot changes, or value changes. Okay, so the three methods to retrieve information: get, snapshot changes, or value changes. So if I remember well, get will get the meta document of the document, meaning that it's the document plus some meta information on what we have, when you have retrieved it, and where is the collection, etc., etc. And it will finish there. It will retrieve this information and then disconnect from the database. If you use snapshot changes, it will retrieve the same thing as get, but it will not disconnect from the database, and then it will be updated each time this document changes. So it's like you still have a pipe from your application to Firestore, and every time the document in Firestore changes, your application gets notified, and then you can treat this information without doing any call on purpose. And lastly, you have value changes, which is the same functioning as snapshot changes, except that you don't have the metadata. You just have the document itself. This is usually the preferred one. Okay? And this yields an observable. Okay? So that's the complex part. So is someone able to explain what is an observable, or nobody has any clue? Okay, Harry?
So, like, I've seen Jeff's video, and I think the best way to explain it is a wrapper that you wrap around the data that you want to observe, and then you can subscribe to this thing, so as to like do stuff with the data you get over time.
Yeah, exactly. So the difference, an observable is more powerful, but it's in the same area than promises. It's asynchronous, okay, and it's called a stream management system, and the power of it is as I said, it connects to a source and stay connected to this source and get updated with any changes. If you use a promise just connect to the source and then get the first update and then finish. Okay, so that's the difference. It stay connected. And
so the difference between this one and the snapshot is that this one doesn't give you that metadata?
Yeah, the snapshot changes, the value changes. The difference is that you don't have the metadata of the document, which is I don't remember what are the
So
metadata.
snapshot would also give you an observable. So
Yes, all three will give you an observable.
Okay.
Also get. The difference is that get, it will be an observable, but it will be terminated. It will give you one result and that's it. So what I usually, when I explain observables and RxJS, I usually use the metaphor of a gardening hose. When you have a gardening hose, a plastic hose, okay, like a pipe, and your data is the water that go through this hose, this pipe. Okay, so when you open the faucet where the pipe is connected, then you start having data flowing inside the pipe. And what you can do is, on the other side of the pipe, you can connect stuff. You can connect a divider to have the flow of information split in two. You can connect any kind of device that will change the water into something else. And you can connect and connect and connect different stuff one after the other. Okay. And at the end, what you have is a subscribe method with a callback function. Okay. It's exactly the same as a promise in this case. So as Harry said, you can also think about that, about observable like topics on I don't know, on Reddit. When you subscribe to a topic, you get notified when there is any change on this topic. Okay, so it will be piped to you, whatever, through any means, email or whatever. Here it's code, because you have subscribed to it. If you don't subscribe to it, you don't receive anything. So if I just stay here, I won't execute anything. I'm just specifying some stuff that are useless. But once I'm subscribing to it, you're going to see that I'm requesting the emitter, the source, to give me information, and I keep connected to this source and want to get all the information each time it changes. So the subscribe function is like a promise. It gets a callback. Usually you have a value. Sorry. And you use an arrow function, and then inside here, you do whatever you do, what you want. Okay, oops, format, auto format. Okay, so I have this document, and then the value change it function, and I subscribe to it, and each time the document in the database will change, this function will be called, and I will print it. So I'm going to try to demonstrate that. So let me check one thing. So this one. Here. Oh, no, I cannot demonstrate that. Not right now. Okay. I can't demonstrate anything because we're not using it anywhere at the beginning. So we have to keep on doing so. So here we have our function get user by email, which is subscribed. And when we receive a value from this document, we will console log the value. So we have to use this in some place.
I don't think you're sharing.
Oh, sorry. You're right. So it's same code. Okay. Let's see how we can do that. So okay, let's do it this way. I go to the app component. I use the constructor, and in the constructor, I will use injection, dependency injection to use my user service. Okay. And here I can call this user service get user by email, and we're gonna, the email gonna be t@t.com. And okay. Oh, I know. Where is the, here? There's the standard Angular crap at the beginning. Okay, everything is deleted. I will explain all that later. We don't need that at the moment. So yeah, it's compiled successfully. So so let's see if I can share that. Okay. 1 sec. I'm just preparing the. All right. Let's see if I can present my entire screen. Oh, cool. Okay. So can you see the two browser windows? No.
Yes.
Okay, so here you already know that this is the Firestore console, and here it's the console of our application. Our application doesn't display anything because we haven't written any HTML. So here, if I start a collection and I call it users, and then the ID is t@t.com, and I will create a name called Patrick, and I save it. And as soon as I save it, you see here, because we have subscribed to Firestore, automatically here we are printing the result of our code. Our code is here. And services, user service. I will put a breakpoint here. So if I change that, for example, I add a field called, I don't know, City Madrid. Oh, it's called again. And now the value is also City Madrid. So each time we have an update on the database, this function here will be called. Okay, this is the main difference with a promise. The promise will be called, will do a request, wait for the answer, and when you get the answer, we'll finish. Observable, they don't do that. They ask for a subscription and then wait for information to come and then use it. Okay. So, where's my code? I think it's not this one. It's this one. Okay. So what we do here in our service, actually, we don't want our service to actually subscribe to this observable. We just want our service to give a mean of the user of the service to be able to access the data, to subscribe to this data. So we do all the dirty work here, and then in the app component here, then we can subscribe or not if we want. But the service itself doesn't subscribe to the information, because if you do that, each time you create a service, you will subscribe to all the collections and all the documents, and it's reading information for nothing, because maybe no no part of the code is using the information at the moment. So what you're doing in your services is defining the functions that will access the information, but don't do it at the moment. So as we said, we have a mean to get a user, but we need also a mean to save a user. So to save a user, here it's red because it doesn't know what user is, so I have to import it. But it's this one, it's okay. It's the user model. And first we have to check some stuff. First we have to be sure that the user has an email, because we are using the email as an ID for the document. So without an email, we don't have any ID. We cannot store the document. So if we don't have any email inside the user object that we are receiving here, we have to throw an error. Like email needed to save a user. And the code will end here. After that, we can return, and then we will use the Angular Firestore library the same way as before. We can use collection. It's our user collection. Our document, it will be the user email. And then here we can set and just the user. Just pass the object that you're receiving. There is another thing you have to do. If you just do that, it will overwrite everything. Okay, so if you, for example, if you want to use one function to create a new document and another function to update this document, you can do in two ways and use different instructions and comments. But you usually don't need that. You just want to save the data. If it doesn't exist, it will create it, and if it exists, it will update it. So what you don't want is for the function to always overwrite the existing information with the new one. What you want is to update it. If there's nothing, it will update everything. If there's already something, it will just update what is needed. So the way to do that is, as you see here, the set function accept two parameters: the data that you are going to save and some options. And the options, there's just one option. It's called, well, there's two options. It's called merge. If you set merge equal to true, what it will do is keep what inside the database and just overwrite with the data you're giving it. But if you have, for example, 3 fields in the database and you're just saving 2 fields, it will not delete the third one. It will just update the 2 that you are passing it. And this one returns a promise. It actually doesn't make any sense to return an observable for saving data, because it just saves it and that's it. There's no further update for it. It's saved and that's it. So this one returns a promise. Oops, sorry. So yeah, we have created our 2 main function for this service. We know how to retrieve a user by email or to save the user with the user information. Okay, it's very, very basic code. There should be more control and more error control or stuff like that, but I want to keep it easy. And lastly, I wanted to show you how, well, this is not a query, okay, to the database. This is just a reference to an object or to a document. Okay, I'm not saying give me the document where the email field is equal to email. I'm just pointing to this document in particular because the ID is email. Okay, this is very different from doing a query, which is what we are going to do now. So if I want to get user by name, for example, and this would return an observable of that user. I will explain that later. Okay. What I do is I again use the library from Angular Firestore, again using the collection, but I don't know what documents they are. That's what I'm trying to retrieve. I want to get all the documents, all the users that has the name equal to this variable. Okay, so what I do here is the collection function has two arguments. First is the path of the collection, and then there's an optional parameters, which is a query, and it's a chainable query, very easy to use. So we get a reference, and from this reference we have a where clause. So here we can do name equal, not equal. We have all these possibilities. So in our case, we want equal. And the third parameter is what you want that to be equal to. So this little function here is the query. Here we're saying, give me all the document where their field name is equal to the value of our variable name. Okay, and this will return an array of users because maybe we have several users with the same name. That's what I'm specifying here. This function returns an observable that will contain an array of users. And as before, I use value change. And here, this is pure TypeScript. Here it says there's an issue. I'm not reading all the text. There's a problem. It's underlined in red. What is the problem? The problem is I'm returning this, but I'm saying that this function returns an observable of the type user array. And here, there's in no place I'm specifying that this collection contains documents of the type user. So that's why the TypeScript is complaining. It doesn't match. I'm saying that the function will get an observable users, but here I'm basically returning a generic observable. That's why it's complaining. So what you can do and what you must do is specify what is the type of document that is stored inside this collection using the greater than and less than symbols to enclose the interface that you've defined at the beginning, the user interface. And that's why at the beginning it's a little bit hard to use typing, but it's so useful because when you use that, then you have all the IntelliSense. When you get this variable, then you know what properties, what attributes all the object have, and you don't make any mistakes. If you retrieve something that is not correct, you will be notified as we were before because it's all underlined in red, so something is wrong. Okay, so I don't know what is. Oh, yeah, sure. Same here. Here we have a promise void. And here we have an observable. Okay, so those are our three functions that allows us to retrieve information from Firestore. I don't know if it's clear. I guess you need time to digest for those who don't know Angular or Firestore. Yeah, Harry.
Okay, so I have two questions. One is in line 28. What is ref?
Okay. So collection. Okay, forget about that for the moment. To make it more readable. Okay. No, I don't know if it's more readable actually. Okay. So collection is a function, as you can see it in the inline documentation. It's a function that takes two parameters. The first parameter is called path, and it's basically the name or the path of the collection that you are querying to. And the second parameter is a function, is a query function, and this is a function. Okay, so we could do that. We could create a function called query function that will get some reference, and then inside this reference I will return that. Why is it red? Oh, we don't care. Okay, and then I can do that. Okay, it's the same thing. I'm defining a function, which is the query function, and this function will be passed one parameter, which is a reference to this collection. It's a reference to the collection. Okay, and this reference can take the where function, where you can pass three arguments, three parameters, the fields you're doing the query on, the operator of the query, and the value that you want to query. Okay, so instead of doing everything outside, you use arrow function. It's exactly the same.
Yeah, so ref is just like the collections reference.
Sorry?
So ref is just the collections reference, just that, right?
Yes. So what is actually happening behind the scene is when you call this function, the library will probably make a call or do some stuff with this variable, check if it exists or stuff like that, and then it will call the second parameter, which is a function. So it will call this function, passing it the ref parameter, which is the result of the work that he has done with the collection function that we've used previously.
I see. Okay. And the second question is, in the get user by name function, we get an observable, but we don't subscribe to it. So do we get any data, or is it just, useless?
That's what I was saying before. What is wrong now?
Oh yeah, we'll subscribe to this observable in another component. Okay.
Exactly. So I don't know what is wrong. Oh yeah, of course. So here in this is the way you structure your code in Angular, or probably in any language. Actually, it doesn't matter, or in any framework. In your service is the place where you define those functions, which are basic functions to access data and to save data, but you don't want it to happen here. You're just writing a tool. Okay, this service is a tool to be used elsewhere to retrieve or set some data in the database. So here you're just basically doing the dirty work, but you're not executing it. You're just specifying how to do it. That's why you don't subscribe. You're preparing everything, and then in the component, here in my component, I've injected my user service, and now if I want, I can subscribe. Okay? Is that clear?
Yeah, thanks.
Okay. And with Angular, it's even easier. What you can do is this. We can do public, oops. We'll call this variable user $. This is a convention. If you specify a variable with $a at the end, it usually means this variable contains an observable. Okay, so sorry, it's an observable of type user, and I have to import user. Okay, so I'm just defining this variable as public, and here I will say this user is equal to this, to the call to this function. I'm not subscribing it here in my code. Okay, I'm just saying the result of this function should be stored inside this variable. So this variable will contain an observable of user. And what I can do then is I go to my template, to the HTML code here, and I can just do user, oops, async. So as in React or in Vue, when you want to use code variable inside your HTML, you just have to enclose them in double curly braces. Okay, it's quite common. And I will explain the async, etc. after that. But if we do that, and then we go back to here, oh, sorry. And 1 and 2. Let me present again, entire screen here. Okay, so you can see both. You can see both browsers, no? Can you see the code and the results here? Or okay, I'm sharing. Okay, so again, if I'm changing this to New York, it will change automatically. Okay, so you don't even if you just want to display the results on screen of what you're retrieving from the database, you don't even have to subscribe. You can use the async pipe as I've written. We will talk that in later session, to let Angular take care of all the subscription and unsubscription to avoid memory leaks and all this stuff. It will just manage everything for you. You don't have to subscribe. You just use the observable. And let me get back to, oops, stop presenting. Let me get back to the code. Oops, here. Okay, inside my user service here, and my app component. So here, as you have seen here, I'm requesting this document from the database, and then in the template, I'm subscribing to it. But what I can do, what is cool with Observable, is that I can pipe some stuff in it. So you use pipe, and you can use, for example, I'm not entering into details. It's too complicated. Just an example. So let me import. I don't know it's not working. The auto importing. Map RxJS operators. Okay, so here I have a user. And we can say that user dot name equal to user dot name dot to uppercase. Okay, and then we return the user. And then I have an error. Where do you have the error? Oh. Okay, so what is cool with Observable is that you can pipe tons of different operators to make transformation on the values. It's the analogy I took before with the gardening hose, when you can plug many tools, something to water the garden that goes back and forth or whatever. It's the same stuff. You have tools that you can use to pipe for the observable, and the data will go through this pipe and all those operators, and at the end, what comes out of all this pipe is the final data. So now if I stop sharing this and go back to here, present window, what is, then you see now the name is all uppercase. Okay, but here it's not uppercase. So the transformation happens inside the pipe, the observable. So you can usually you do all your transformation in your service. For example, if you want to retrieve different pieces of different data from different places inside your database and then merge together and then transform or multiply numbers together, you can do all that inside the observable and just have one subscription. And each time the data changes, it will go through the pipe and repeat all the transformation. So you don't have to manage all that. That's cool about ArcGIS. Okay. I don't want to go any further right now. I think it's a lot to process for you, probably. Do you have any doubts about what we've just seen, or more questions? I will upload everything on the GitHub repository, and I will post all the details on the Slack channel for you to check it and see what the code. And if you want to ask more technical question after that on Slack, no problem.
And you were able to record today? I came in a little late. I got the times mixed up.
No worry.
Yeah. So you'll post the video also?
Yeah. I started recording a little late, but I think I missed we went through the PDF I sent because
for the setup. Okay, I did that. I was fine with that part.
Yeah, Neville had some trouble, and also Michael, so we solved some of the issues. If you haven't had any issue to follow the guidelines, then you're not missing anything.
Okay, great.
Okay, any more question? Okay, so we'll leave it here. I will post everything on Slack and try to use it, try to play with it, and ask questions. I think it's also easy to answer everything on Slack, writing than just explaining case by case on video. Okay.
Cool.
Thank you, Patrick.
Okay.
Thank you.
Thank you, guys.
Bye.
Goodbye.
See you. Bye.